in this session we will be talking about the concepts of tsunamis. We have already covered a lot of topics in oceanography. Tsunami is one of the contemporary topics because of the 2011 tsunami that happened. So we will be covering this topic in detail today. Our major focus would be measurement, causes, hazards and prediction related to tsunamis. Now the word tsunami itself is derived from a Japanese word, or I could say it's a Japanese word that means harbor waves. The waves that touch the harbor are known as tsunamis in Japanese language. Now, the interesting thing to note about tsunamis is it was previously known as tidal waves. However, these tsunamis are not caused due to tides. So the most important thing to remember here is they are not caused due to tides. However, they were called as tidal waves in the ancient times. But these tidal waves are caused due to extraterrestrial objects. I could say influence of moon. So moon leads to tidal waves. However, tsunamis are not tidal waves. They are harbor waves rather. Now, what are exactly tsunamis? If I say there is a sudden displacement of huge amount of water, that would be known as tsunamis. When they strike the coast, they cause a lot of destruction. So in this image, you can see this is a kind of settlement that was in existence before the tsunami, and this is what happened to that town after the tsunamis. So tsunamis lead to huge destruction. Now, in tsunamis, the main and the important idea is there are series of waves, and these series of waves are known as wave train. So I can say there is a kind of train of waves that is gushing towards the coast and causing destruction. Another important thing to note here is I say tsunamis are series of waves or are wave trains, but still there can be difference between the two consecutive waves as large as 1 hour. So usually people believe that there is a sudden gush of water towards the coast, but the difference between two consecutive large waves that is touching or destructing the ocean could be as high as 1 hour or 2 hours. So the important thing to note here is there is deformation that occurs under the sea floor, and that deformation that's occurring under the sea, or I could say towards the sea floor, leads to vertical displacement of water. So this vertical displacement of water, I am writing it as H2O. So vertical displacement of water would lead to the tsunamis towards the coast. Now before we start understanding the characteristics of tsunamis, we will first focus about the basic ideas of wave. When I talk about wave, if the wave is at a resting potential, the point or the highest point that a wave can reach is known as the wave crest. The deepest point it can go is known as the wave trough. The difference between the crest and the trough is known as the height of the wave. And this height of the wave is the major determining force behind tsunamis. So the first thing that we need to understand here is height, which is a major determining force for tsunamis, and next half of the wave height is known as amplitude. That's from the resting potential to either the crest or the trough would be the amplitude of the wave. The difference between two consecutive crests or two consecutive trough is known as wavelength, and we denote it by a sign of lambda. So that is the wavelength. So we have talked about wave height, we have talked about amplitude, crest, trough and wavelength. Now the time taken by the wave to cover one wavelength is known as the wave period, and the speed by which the wave moves on is known as the wave velocity. So these are another two things that we need to understand about waves. Now once we are familiar with these concepts, two things determine the tsunamis. First is the height of the wave and second is the velocity of the wave. So the most important features here is the height of the wave and the velocity of the wave. Now we have an interesting video that will help you understand how waves are caused during tsunamis and what is the effect of the waves as it reaches the coast. So you have a video here. Now if I play this video, you would see a ship that's in the deep waters. There is a tsunami in the deep water, but this ship is in a constant position despite of the huge tsunami. But as the waves reach towards the coast, these waves start to break at the coast and these cause destruction towards the coast. However, despite of the flow in deep water, that boat would remain unaffected, but if the boat is closer to the coastline, that boat would definitely face a lot of damage. So the damage is most predominant towards the coast. Let's understand how this works. So I have a diagram here. We have the depth, the velocity and the wavelength. Now towards the deeper oceans, most of the energy here is stored as kinetic energy. However, towards the coastline, this energy gets converted into potential energy. We believe that total energy remains constant. So what is happening in the deep oceans? In the deep ocean, say at a depth of 4000 meters, you have very high velocity and huge wavelength. However, as you move closer to the coastline, the velocity is decreasing and so the wavelength is decreasing, but there is amplification, that is the height of the wave is increasing. So the total energy stored is constant. The velocity here, the main key here in the kinetic energy is the speed, and here energy is stored in the form of amplitude or height of the wave. So as we move towards the coast, the height of the wave increases and the wavelength decreases. So there is decrease in lambda but increase in height. However, in the deep oceans, the wavelength remains nearly constant. When the height of the wave increases towards the coast, it causes huge destruction on the coast. So that's the basic idea behind the concept of tsunamis. Now we will be talking about some of the major characteristics of tsunamis. First, velocity is represented by root of gravitation and depth of water. That means velocity is directly proportional to depth. So as the depth increases, the velocity increases. That's clear from this diagram. So you are increasing the depth and velocity is increasing, or I can say the depth is decreasing and similarly the velocity is decreasing as you move towards the coast. That's the first thing to note. The second thing to note here is total energy remains constant. However, the only thing that's happening here is transformation of energy. So energy can neither be created nor be destroyed. It can just be transformed from one form to another. So kinetic energy is being transformed into potential energy as it reaches towards the coastline. That's the second phenomena we need to understand. So first is, we have talked about the concept of velocity. Secondly, we have talked about the concept of transformation. And third is the rate of energy loss is inversely proportional to wavelength. So if the wavelength is more, energy loss is less. Towards the coast, the wavelength decreases and energy loss increases. So the rate of energy loss is inversely proportional to the wavelength. So these are some of the major characteristics of tsunamis. Now there is an interesting question that arises. We talked about wave. We said there is crest and trough. If the crest reaches the coastline first, so suppose this is my coastline and you have the crest that reaches the coastline first. What would be it known as? It would be known as run-up. And that's very simple, because there is a height, it would cause direct destruction towards the coast. So run-up is due to crest that collides with the coastline first and it leads to direct destruction. But what would happen if the trough touches the coast first? So I have this as the coastline and I have a deep trough that is touching the coastline first. If a trough is touching the coastline first, there would be drawdown. Drawdown means the water would slightly move back and then push it forward. So there would be a kind of things coming towards the ocean and then retreating back. So that would be known as drawdown. So when tsunami occurs, the phenomena can be either run up or drawdown. So if there is run up, there would be direct destruction on the coast. So there would be huge wave that would be coming on the coast and all the vehicles or all the roads, all the nearby residences would get destructed. However, if there is a trough that collides with the coast first, there would be drawdown. That means the things that are towards the coastline would be forced towards the ocean and then they would retreat back with the crest that comes up. So these are the two basic phenomena we need to understand. Now, the next is how we can measure a tsunami. We can measure tsunami by two major aspects. One is the magnitude and the other is intensity. When I say magnitude, we are focusing on the potential energy. So whenever I say I am measuring it by terms of magnitude, what we are understanding is we are analyzing the potential energy, and the other is intensity, how strong the tsunami is. So to measure the intensity, there are two scales that were given. Sigburg-Amsray scale that was used in the Mediterranean Sea, and then you have the Imarua-Leda intensity scale that was used in Pacific Ocean. However, there was a scientist who was known as Solovey. Solovey along with Imarua gave an intensity determination scale with this formula, and where HAW was the average wave height. The next was magnitude. Magnitude was given by Abe. So Abe gave this formula to understand the magnitude, and he talked about H as the maximum amplitude, D, B and A as the constants that were calculated, and the distance from the tide gauge was R. So these were some of the formulas that were propounded to understand the role of tsunami or the intensity of tsunami. Now, the next important thing is, how are tsunamis caused? The most common explanation that you could refer is either by earthquakes or volcanoes. But these two are not the only causes for tsunami. So let me have a quick world map here. So this is South America. I am drawing a rough map. So that's North America, and you have Africa on this side. And if I try to see, this would be Australia, and this would be Japan and Indonesian islands. So this whole region in the Pacific is known as Ring of Fire. So the region surrounding the Pacific is known as Ring of Fire, and this Ring of Fire is prone to lots and lots of earthquakes and volcanoes. And this we have already talked about in the class on plate tectonics, how this happens. Now, earthquake, if I talk about, that is one of the primary reasons for tsunamis. It's directly proportional to the size of the earthquake. So if the velocity is high, there is a lot of vertical displacement, and that would lead to earthquake in the water, and if the earthquake occurs beneath the water, that would lead to tsunami. So some of the common examples are the 2011 Sendai earthquake in Japan, where there was a level 7 warning declared for nuclear reactors, especially for the Fukushima nuclear reactor. Then there were numerous other earthquakes that were in the Alaskan coast and Nicaragua in 1992. That led to tsunamis. The next is volcanic eruption, common around the ring of fire. It's usually said that every year there are 1 or 2 tsunamis that occurs in the Pacific, and every 10 to 12 years there is a huge tsunami that occurs in the Pacific. So volcanic eruption is another important cause. Some of the important volcanic eruptions: in 1983, Karakota, that led to a huge tsunami, and then there are some other reasons as well. One is landslide. So if there is beneath the ocean, you have landforms similar to you have in the earth's surface. So you have mountains beneath the oceans. So if there is a landslide that occurs beneath the ocean, so you have a mountain with rocks tumbling down, that would again lead to a huge tsunami, and those tsunamis are caused due to landslides. A common example was 1985 Lithia Bay in Alaska. Then there can be underwater explosions. This happened in around 1940s and 50s when US was testing its nuclear weapons at the Marshall Islands. So testing of nuclear weapons or underwater explosions, if they are happening in the ocean, that would lead to tsunami or huge waves on the surface. And finally, most important is meteorite impact, that most of the lectures you will see missing in. So meteorite explosion, if there is a huge meteorite that is coming on the earth and that drops down into an ocean, the impact of that meteorite would be such huge that it would lead to a huge wave or tsunamis in the ocean. That happened around 3.5 to 6 million years ago in the Cretaceous period, and that led to a huge tsunami during the Cretaceous period. So there are 5 basic causes that lead to tsunami. Now next is hazards. When I talk about hazards, we can classify hazards into 3 types: the primary hazards, secondary hazards and tertiary hazards. Primary hazards are the immediate hazards that cause most of the destruction. So first is the primary hazard that affect the coastline and cause severe destruction. The second is the secondary hazards. These can be in the form of debris flow. You have erosional elements. So you have erosion of huge number of elements that happen, and finally fire from the gaseous eruptions that occur. So if there is an underground eruption, there can be fire from the gaseous eruptions. So these are some of the secondary hazards that occur, and finally you have the tertiary hazards. Tertiary hazards that you can visualize on the land. So there can be loss of crop, loss of life or deaths, I could say. Then there could be famine and floods situation, shortage of electricity. All the power lines can break down, so there can be shortage of electricity in that region. There can be huge power cutoffs. So these are some of the tertiary impacts that you can visualize because of tsunamis. Now the last thing that we would be covering in this lesson is prediction of tsunamis. When I say prediction of tsunamis, that means how can we detect whether a tsunami is about to come or not. So if we talk about statistics and we try to understand the importance of prediction, we'll get to know, if I take a case study of Japan, before prediction and after prediction, what are the differences? So before prediction, there were around 14 tsunamis that hit the coastline of Japan, and these 14 tsunamis led to around 6,000 deaths. However, after the prediction system was installed, there were 20 tsunamis, and these 20 tsunamis led to merely 215 deaths. That means the prediction system is working very well and very strongly, and it's good that we have the prediction system in our go. Now, the prediction system can further be classified as a kind of hierarchy, the largest, the smaller and the least. So you have the Pacific warning system as the biggest ambit, which covers around 26 countries, and the headquarters are maintained at Honolulu in Hawaii. So Hawaii Island of US maintains the headquarters of Pacific warning system, and this warning system has specifically been installed in Pacific region because, as we previously told, there is ring of fire in the Pacific Ocean which is prone to earthquake and volcano, because of which there are huge number of tsunamis that affect the Pacific coast. The second is the regional warning system, that's at a lesser level than the Pacific warning system, and finally you have the local warning system. So local warning system is by the local city, county or the local municipality that governs it. Regional warning system is by individual country. Some of the major regional warning systems installed are at Japan. Then you have Kamchatka, Alaska, Hawaii, French territories, so the islands of Polynesia. So these have some of the regional warning systems. However, Pacific warning system is the biggest warning system. It supplies data to NGDC, NOAA and the Novorossiysk warning system. So NOAA is the National Oceanic and Atmospheric Administration, and NGDC you have as the another warning system that governs this region. So the main role, the National Geographic warning system. So this Pacific warning system issues warning. The warning threats are issued around 4 hours prior. So there is 1 hour time frame that is used to integrate all the data from the various regional centers, and within 1 hour, once all the data is integrated, it tries to provide warning 4 hours in prior to a tsunami touching the coast. So it gives ample of time for people to get prepared and to have a kind of self-defense. The best self-defense that the guidelines provide is moving on to a high altitude area or towards the inland away from the coastal area. So these are some of the major guidelines that are provided under the warning system. So in this session we have talked about the causes, the hazards, the prediction, measurement and the basic characteristics of tsunami waves. We will be covering more topics in geomorphology, in geography, especially geomorphology and climatology in the further sessions. You can subscribe to our video for any further updates. Have a good day.